Good day, students. Welcome to another episode of Chemistry Made Easy. Today we'll be looking at another topic in chemistry which is very, very important, and that is electrolysis. Electrolysis. This topic is common in UTME, it's common in SSE questions, and some students have difficulty in getting right answer for questions on the electrolysis. So, today we'll be looking at the first part, which includes definition of electrolysis and preferential discharge of ions during electrolysis. So let's start. Let's start with the definition. What is electrolysis? Electrolysis can be defined as the decomposition or breaking down of electrolytes through the passage of electricity, in which free molecules of elements are liberated. I repeat, electrolysis is the decomposition or the breaking down of electrolytes through the passage of electricity, and this leads to liberation of free molecules of elements. So, when electricity passes through electrolytes, it breaks it down, and in the end, there will be liberation of elements or atoms. So let's define some common terms used under electrolysis. Some terms used under electrolysis. The first term is electrolyte. Electrolyte. What is an electrolyte? An electrolyte are substances which allows the passage of electricity and are decomposed by electricity. Electrolytes are substances which allows the passage of electricity and they are decomposed by electricity. When I say decomposed, I mean breaking down. They are broken down. When something is being broken down, it's being splitted into its components. So electrolytes are splitted into their components whenever electricity is passed through them. Now, note something. Electrolytes must either be in solution or in molten state. Electrolytes must either be in solution or in molten state. If you have a substance that is a solid, such substance cannot be an electrolyte. It must either be dissolved in water or be dissolved in other solvents, and or be in molten state. A molten state is a state of matter in which it is melted. It does not contain water or any other solvent. It is just melt it. For example, your candle wax is molten. So electrolytes must be either in molten state or in solution form. Now, examples of electrolytes. We have acid. Acid solutions are electrolytes, e.g. your H2SO4, HCl, HNO3, even ethanoic acid, they are electrolytes. Either they are concentrated or diluted, they are electrolytes. Then your alkaline solutions are also electrolytes, e.g. that's your potassium hydroxide, your sodium hydroxide, calcium hydroxide. Your alkali are usually electrolytes. Also, salt solution are electrolytes, e.g. copper sulfate, sodium chloride solution, silver nitrate solution, lead nitrate. Any salt solution are also electrolytes. Alright, now that's about electrolytes. Let's go to electrodes. What are electrodes? Electrodes are materials through which electricity enters or leaves the electrolytes. I repeat, electrodes are materials through which electricity enters the electrolyte and also through which electricity leaves the electrolyte. Either it allows electricity to enter or it allows electricity to leave. So such substances are electrodes. They are usually metals or solid. Let's say they are usually solid. Yes, because some are not metals actually. They are usually solid in nature. So assignment, please, I need you to give me the similarities and differences between electrodes and electrolytes. Please send it to me on my comment section. The differences between electrolytes and electrodes. Alright, so let's move on. We have two types of electrodes. We have the anode and we have the cathode. Two types of electrode, anode and cathode. The anode is a positively charged electrode, while the cathode is a negatively charged electrode. I repeat, the anode is the positively charged electrode, while the cathode is the negatively charged electrode. Okay, let me give you the simple diagram of electrolytic cell. So this represents your electrolytes. You can use copper sulfate solution. I can pick this one as my anode, and this one can be my what? My cathode. Positively charged anode, negatively charged cathode. So the electricity enters through the anode. As you can see, electricity enters from this position, enters there, then goes into the cathode. So it enters the solution. And this is your electrolyte, copper sulfate, which is being decomposed by the passage of electricity. Your copper sulfate is being decomposed by the passage of electricity. So that means your CuSO4 will break down into different ions, either cations or anions. Let me show you what you will see when it is composed. You will see Cu2 plus, that's one of the ions that you will see. Then H plus will be present. Then SO4 2 minus, that's your sulfate ion. And then you now have your hydroxyl ion. So this is a simple diagram way of representing your electrolytic cell. All right. Let's continue. Let's look at some other concepts. I've already explained electrolytes and types of electrolytes. I've explained electrodes. And note this. This is actually very common in the exam question. Oxidation takes place at the anode, while reduction takes place at the cathode. I repeat, oxidation takes place at the anode, while reduction takes place at the cathode. Now let's move on. Let's move on to the ions that are being formed when your electrolytes are decomposed. The ions that are being formed when your electrolytes are decomposed. We have two major ions that are formed. We have the cations and we have the anions. The cations and the anions. Now, the cation, this is the positively charged ion, and this ion migrates to the cathode. The cations are the positively charged ion, and it migrates to the what? Cathode. While the anions are negatively charged ion, and they migrate to the anode. Note, the anode is positively charged, as you can see, but anions are negatively charged. Anode is positively charged, but anions are negatively charged. Why? Because unlike charges attract, negative charge goes to the positive electrode. Why? Negative, where positive ions goes to the what? Negative electrode, because unlike charge we attract. All right, so using copper sulfate solution, let's look at the ions that will be formed from copper sulfate solution. So the cations will be Cu2 plus, H plus, and the anions will be OH minus and SO4 2 minus. So these are the ions that we have when copper sulfate is being decomposed or is being broken down. All right. So let's move on to another aspect, which is the preferential discharge of ions during electrolysis. Preferential discharge of ions during electrolysis. Now, what does this talk about? The word preferential means having preference for something over another thing. For instance, if I have preference for rice, I prefer rice to spaghetti. Now, in the case of electrolysis, when we have two competing ions, and one of the ions is being discharged or is being liberated in your electrolyte, what makes the ion to be liberated depends on some factors or on some conditions. So we're looking at the factors that affect or that makes an ion to be discharged during electrolysis. So we call it preferential discharge of ions during electrolysis. So let's start. So the first factor to consider is position of ion in the electrochemical series. The position of the ions, number 2. Nature of electrode. And number 3 is effect of concentration. So these factors are, number 1, position of ions in the electrochemical series, the nature of electrode, and effect of concentration. So let's start from the first factor, position of ion in the chemical series. Now let me tell you this, let me remind you this, when you have your electrolytes, I told you they are being decomposed by electricity to liberate ions. In the case of copper sulfate is being decomposed to give you copper 2+, hydroxide, hydrogen ion, and sulfate ion. So in these ions that are formed during decomposition, only one of the anions will be liberated, and only one of the cations will be liberated. So what are the factors that make those ions to be liberated? So it's what I call the position of ion in the chemical series. So the first one, position of ion. Now, listen to this. Cations that are lower in the chemical series are discharged in preference to those that are higher in the chemical series. Cations that are lower in the chemical series are discharged in preference to those that are higher. So let me show you the series. Now, potassium is in the top of the series, followed by sodium, calcium, magnesium. Let me start from here. The top is potassium, sodium, magnesium, calcium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. These are the this arrangement shows the position of ions in the chemical series, and you can see the topmost is potassium. So the rule says that ions that are lower in the series, they are discharged in preference to those that are higher. So that means the preference goes down. So in a solution that contains potassium and calcium, for instance, calcium is lower in the series, so calcium will be discharged, while potassium ion will be left in the solution. That's for cations. So that means if I have copper sulfate solution, and my ions are Cu2+ and H+. This is my anions. And my cations. This is my cations. So which of them will be discharged? You can see it is copper that will be discharged, because copper is lower than hydrogen in the chemical series. So the ions that are lower are discharged, while those that are higher are left in the solution. Now that's for your cations. Then for your anions. So we have hydroxyl, iodine, bromine, chlorine. Then we have nitrates, sulfates. Then we have fluoride. So in this case, the trend goes upward. So the ions that are up in the series are discharged in preference to those that are lower. So in this case now, hydroxide is the one that will be discharged over all other ions if they are in the series. So let me go back to copper sulfate solution. That we have OH and SO4 2-. If these two ions are the competing ions in your chemical series, which one do you think will be discharged? Of course, it is the one that is higher that will be discharged, which is what? Hydroxide. Now, for anions, those ions that are higher are discharged, but for cations, those that are lower are discharged. So, on this note, I will end the past one aspect of electrolysis. So, in the volume 2, I will be discussing other factors like effect of concentration and effect of nature of electrode. Also, I'll be looking at uses and the application of electrolysis. So, till we see again next time, thank you. I remain your humble teacher, Bolaji Bakari.